So hello everyone. So today I will talk about robot learning. And let's imagine that you have just bought a robot from your neighborhood store. And a robot here is a system that interacts with the world. So here on the top left, you can see a Boston Dynamics Spot robot climbing up the stairs. It has 4 legs and an arm. Here on the left bottom, you can see an excavator. It's kind of like digging earth, so both could be considered robots. In my research group, we also consider different kinds of systems, for example, mobile phones and bioprocesses and so on as robots. Now, let's say you have the robot now at home, and you want the robot to do something. And let's imagine 3 different wishes you would have for the robot. For example, bring you a cup of coffee, clean up your apartment, segregate waste. So how can you actually make the robot do those things? So what has been done already for quite some time is just that you could program the robot to do a specific task. For example, in factories, for example, car factories, there are robots that take a car door, move it from point A to point B, following always the same trajectory. So the robots always do the same predefined movements in a controlled setting. But what if you want the robot to do actually something more complicated? What if you want the robot to actually go to a new home and do something, for example, clean up the home? How can you accomplish that? So what if a human goes inside a new apartment? So then the human needs to learn how to clean this apartment. And this is also exactly what my research group focuses on. So my research group focuses on learning, and especially making robots do complex tasks, even completely on their own. Now, the next question is that if you have this robot and you decide that, okay, I want the robot to learn something, how can you actually do the learning? And what humans often do, for example, as children, also as adults, is that they follow other humans' behavior. And this is kind of like the first point here. A robot could actually follow a human, human could show a robot what to do. And I will show an example of this. So here we have again the Boston Dynamics Spot robot with 4 legs and arm. But in this case, the robot also has a camera attached here at the front, and it can see forwards. And when the robot is now controlled by a human using a joystick, moving the robot body and the robot arm for manipulation, the robot moves, and at every time step, the robot sees the environment using the camera. The robot stores this image into its memory, and at the same time, it also records what the human was doing with the joystick. For example, if the human operated the robot arm, the robot remembers, okay, now when I see this image, I need to use the mobile arm. And here's an example after the human has shown a task when the robot actually executes it. So here the robot sees this table, goes towards the table, then at the table it sees, okay, there's this cover, I now need to pick it up. It sees the cover is in the air, okay, now I go left. Okay, now I see another table, I need to drop the cover, and now I can go left and then down, and then the task is finished. And here the whole task was successful. And this can be replicated with many different kinds of tasks. Now, why is this task, for example, here interesting? Well, first of all, now that the robot does everything based on the images or observations it makes, the observation somehow has to match the demonstrations. And here we have actually changed the cover. So it's not the same cover, it's a different color. And we have also moved the robot to a little bit different position at the start. So the robot does not see exactly the same images, but different kinds of images. And this is something that our research group focuses on in our research. We want to develop machine learning methods that allow the robot to match the observations it makes to the demonstrations that the human provided, so that we can actually then apply the same learning to a little bit different kinds of situations. Now, In this case, the robot was successful, but if you would now take the robot to your home and show it how to clean it up, and then you would bring it to your friend's home, it probably could not do it. It could not clean up your friend's home because it would be completely different. So what do we need now? So what do humans actually do? So humans learn on their own. If they go to a friend's house, they learn to clean it. And the robot can do the same thing. And the simplest way maybe doing this kind of like learning is that the robot starts randomly moving its legs, for example, and then it just remembers which movements actually succeeded or provided the desired outcome. This takes, of course, a long time to succeed, but it's possible. So here we have a left top, we have a robot dog or a dog, and on the left bottom we have a humanoid moving rapidly forward, and they have learned to move on their own. They look a little bit strange, like I call this the crazy dog, and this is because maybe the simulation or optimization don't match the real world. But what is important to here recognize is that to actually make the learning work efficiently, we need to act intelligently. So it's not enough that we just do random movements. We also need to somehow choose what is the information the robot needs to actually accomplish the task. And here's another example of robot hands playing a piano. And here we have also used some robot learning techniques to teach the robot hands how to play Flight of the Bumblebee. And the important thing here is to recognize that the robot needs to retrieve the correct kind of like information when it learns to be behavior. For example, if a robot wants to run, then it first needs to learn how to move its feet. Or here, for example, the robot needs to learn how to position the fingers correctly on the keyboard. And the important thing is that the robots always needs to consider what is the things it doesn't understand, what are the parts that are missing from the solution to the task it needs to perform. It needs to collect relevant information. And when the robot does this, it can actually start to learn even more complex tasks. Now, so far we have been discussing kind of like doing random movements and then kind of like doing the movement or actions of the robots a little bit more intelligently so that we only collect relevant information about the task we want to perform. But how do actually humans perform tasks or learn more complex skills in the world? So as children, for example, you maybe learn to read, but you don't read sentences. You don't start by reading sentences, but you learn by reading letters first, and then maybe words, and then sentences. So what you do is you start from learning from easy tasks, and then you progress toward harder tasks. And here on the left top, we have an example where we have multiple robots, and they try to move through a door. And in this case, the final task that we want to solve is just moving through a very narrow door. But in order to make this thing easier, we can advance from easy tasks to difficult ones. So we can actually change the size of the door. We can start from a very wide door, and then the robots it's easy for the robot to learn to move the legs so that they get through that door, and then we slowly shrink the door size. And finally, we can do the more challenging task. Of course, there's still one problem remaining, and this is something we have been focusing on in our research. And this is that if you choose a very specific task, so how do you actually choose it? It's not so easy. So if you choose a very easy task, then the robot can quickly do it, so it learns how to do the new task, but it might be that the new task is very far from the final task that we want to solve. So we have not made really progress, Another possibility is that if we choose too hard tasks, then the robot does not make any learning progress at all. So what we have been using in our research is actually using a distribution over different kinds of difficulties of tasks. And then we start from one distribution and move the distribution towards the target distribution of the task. So then the robot can learn at the same time many different tasks and many different difficulties to accomplish the task. Okay. So now, until now we have been now discussing how the robot can imitate human behavior. Then we discussed how the robot can learn on its own just by random movements, then a little bit more intelligently by choosing the movements which it doesn't know about yet, and then about this kind of like curriculum learning, where we can start from an easy task and more to move towards more difficult ones. Now, in all of these cases, the robot interacts with the world, and it learns about the world. For example, when the robot sees an object, a chair, it can push the chair, and it learns that the chair moves when you push it. And this is what happens in all these cases. Now, if the robot then actually takes this information about how the world functions, it can start imagining possible different futures. So it can start planning how to accomplish a task. For example, it can plan that it first moves the leg like this, and then a little bit further. Or that if it does like a complicated task like assembly, it thinks about, okay, putting first an object here, then another on top of it, and so on. So in this kind of like planning, we have also made advances. So we have, for example, created methods that can do long-term planning, and these methods then allow us to solve more complex tasks. And examples of tasks where we have applied these planning methods are, for example, humanoid movements in simulation, or then we had even a real robot disentangling waste material from each other, even though the robot was not familiar with the environment beforehand. To conclude the talk, I want to say that when we do robot learning, so when we allow the robot to learn new kind of like behavior, it requires efficient use of the information and also efficient gathering by the robot of the information that it needs to perform the task it's trying to do, and also maybe sometimes guidance. In the end, it matters how you learn. Thank you.